Welcome back everyone. So, in last part we are discussing about the daily, that means the energy between the successive energy levels. So, that is actually that will be decreased while the n is increasing. Okay, so let me do that explicitly. Let us consider this. What will be if we put here, then daily to 1 should be, here n is 1 because this is formula is for n plus 1 and minus n, that means n plus 1 is 2 and n is 1. So, if that is the case, then that will be RCH and it will be 2 plus 1 divided by n is 1. So, it is 1 square plus 1 plus 1 square, right. So, it will be RCH, RCH is constant, that will not depend on n. So, it will be 3 divided by 1 into 4. So, 3 by 4 RCH, correct. So, now similarly, if we do that for 3 2, it will be RCH. Now, here n is 2 because n plus 1 is 3. So, n should be 2. So, that means it will be 5, correct, divided by 4 into 9. So, it will be RCH into 5 36. So, this is the case. So, now 3 by 4 or 5 by 36, which is greater? So, clearly 3 by 4 is greater than 5 by 36, much more greater than 5 by 36. So, should be daily is very daily between energy gap between first and second level is much more greater than third and second level. So, that we can also see from here, because what was the general form, that En is actually minus 13.6 electron volt divided by n square. So, E1 is essentially minus 13.6 electron volt, E2 just we have to put n equals to 2, then that will be minus 13.6 divided by 4, and that is actually 3.4 electron volt. Similarly, what will be E3, just we have to do n equals to 3, so it will be divided by 9, so that will be minus 1.51 electron volt, and just E4 is minus 0.85 in similar fashion, and it goes on. So, we can see the energy gap between 2 and 1 is around 10, we can say around 10, but 2 and 3 is just around 2. So, it decreased, okay, it decreased, and we know that for free electron the energy is 0, correct. That we can also evaluate from here as well. Let us say n equals to infinity, because in principle n can goes up to infinity. In that case, E infinity will be, okay, and infinity means it should be 0. So, infinity is 0, that means when that electron will roaming about in the infinite orbit, then that will, the energy will be 0, and for infinite orbit radius will be Rn. What was Rn? A naught n square. So, that will be infinity. So, that means for infinite orbit radius will be infinity, and for that orbit the energy of the electron will be 0. That means that in physically, that is, let us say okay, what? Okay. So, that means this is electric field of nucleus, let us say. That means electron, if infinite means not very large value, then essentially does not mean, we have a misconception about infinity. What is the infinity? Infinity does not mean 10 to the power 100 times, nothing like that. Infinity may be 10, okay, or infinity may be 1 as well. So, infinity is not a fixed number, infinity depends on the situation. Let us say if we give an example for a middle class family, if we consider that, for which the annual income, let us say around 2 lakhs or 3 lakhs, for those 1 crore or 2 crore is infinity, like infinite, right. But for a very rich family, 1 crore 2 crore is not infinity, for that 1000 crore 2000 crore may be infinity. So, infinity, it depends. The definition of infinity is, at that value, at that infinity, everything can be achieved, okay. That means if energy is infinity, that means that with under that situation you can do anything. you don't have any restriction, and 0 means you have all restriction. That is the difference between infinity and 0. So here electron is free, that means it has all liberty. That's why it's the energy, the radius is infinity. That means out of the field of the nucleus, it's totally free, there is no restriction. So that does not mean that the radius should be infinite, because we know that we have also seen that for magnet, we know for magnet there is also magnetic field, and in principle the magnetic field should vanish at infinity, but we know after some distance the magnetic field does not work. That means that infinity actually finite for our scale. Our scale, that length is finite, but for that magnetic field, that scale, that atomic scale, we can say that distance is infinite. So we have to be crystal clear about the infinity. Okay, so for E infinity it's 0. That means it's out of the atom. There is no force of nucleus on that electron under that condition. It's totally free. Okay, so now if we draw that, okay, so in this axis we plotted En. So this is 0 and En is negative, so it should be, and in this axis we have plotted N. No, not N. So this is 0, so it should be N equals to infinity, where the energy of the electron is 0. Now for N equals to 1, these are the energy levels, we are drawing the energy levels, that's it. Okay, this is N equals to 1, so energy should be minus 13.6 in electron volt, okay, in electron volt. Now for N2, N equals to 2, that means E2 is minus 3.4, so it's maybe around here, it's not up scale, so it's minus 3.4. Now it's E3, so let me here it should be. Okay, so for E3 it's N equals to 3, it's minus 1.51. N equals to 4, and this thing, it will be more closer if you increase the N, right, like this. In principle they are infinite, but if you consider properly, then there will be 6th or 7th energy level exists basically. After that it will be a continuous band, and then it is N equals to infinity and energy is 0. Okay, so this is the energy levels. Now if you make the transition between these energy levels, then obviously there will be absorption of energy, absorption of radiation or emission of radiation. If it is de-excitation, then emission will occur. If it is excitation, then absorption will occur. So this will be discussed in the part of atomic spectra. So this is total about the energy part. Now we will discuss the speed. Speed of electron in the nth orbit. This is also important, correct? Okay, so what was the expression of V? What was the Vn? If you remember, basic condition was mvr equals to nh by 2 pi, right? And the Vn was Vn square, actually Vn square was 1 by 4 pi epsilon naught E square by mRn, because we have put the z equals to 1. So Vn square is proportional to 1 by n, so we can write it, not this V. Okay, so this should be proportional to root over Rn, correct. And again we know that Rn is a naught n square, correct. So if we put that here, so root over Rn should be root over a naught n, and a naught is constant, so a naught we don't need to write a naught, so it will be direct 1 by n. Okay, that means V1 proportional to 1 1, only 1, with a constant there. If you give the equal sign, then there will be a constant. Okay, V2 will be proportional to 1 by 2, V3 will proportional to 1 by 3, and goes on. That means we can write V1 is to V2 is to V3 is to V4 dot 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 equals to 1, 1 by 2, 1 by 3, 1 by 4 and goes on. So, this is the ratio. Okay. So, that means the speed is decreasing, right? It should be, it's inversely proportional with n. So, if you increase the orbit energy level or n, then the speed will be decreased. Okay. Now, we have to evaluate the form as well. So, this is the Vn square. So, here from here we can write Vn equals to 1 by E square divided by mVnRn. Just I bring one Vn here in this side in denominator, and we know that mVnRn equals to nh by 2 pi. So, if you put that, this should be the case, correct. So, this is the case. So, right, pi will be cancelled out, 2 will be cancelled out. So, it will be E square divided by 2 epsilon naught nh. Okay. So, it is not unitless, it has a unit. So, make it unitless. So, we know that c is the speed of light, okay, and c is also fixed constant. C is 3 into 10 to the power 8 meter per second. So, when divided by c, then it will be we can write it, okay, that it is it's we can write it like this. This part is constant, everything is constant, E, C, epsilon, H, everything is constant, okay. This is written as alpha. What is alpha? Alpha is called Sommerfeld, not F E, just Sommerfeld's fine structure constant, okay. So, it is alpha by n. So, you can write Vn equals to C by n into alpha. Alpha is also constant, okay. So, this is one important relation, C by n into alpha, okay. So, now if you do it for n equals to 1, then it will be C by n, just C by n into alpha, and n equals to 1, that means it will be C alpha, it will be C alpha. So, and alpha is a constant. If we what was the alpha? Alpha was E square divided by, okay, E square divided by 2 C, 1 minute, what, there should be a 2 pi, right, and is by 2 pi, yes, 2 pi should be there, okay, it's correct, it's correct. So, E square divided by 2 C epsilon naught H, E square divided by 2 C epsilon naught H, this is E square, okay. So, if you put the values, then you can obtain the alpha is actually 1 by 137, it is a constant without any unit. So, for V1 we can write it. So, V1 is just C by 137. So, the speed of the electron which is revolving around the nucleus in the first orbit, that speed will be 137 times less than the speed of the light. So, if you put the value of C 3 into 10 to the power 8 meter per second, then it will come out 2.18 into 10 to the power 6 meter per second. So, this is very fast, very high speed. That is why for dealing with this speed we need to do the relativistic calculation. So, that is not in our course. So, what will be V2? V2 will be C alpha by 2. So, it will be just 1.09 into 10 to the power 6 meter per second. Similarly, V3 and it goes on, okay. This part, this is the speed. Now, one thing is left, that is orbital angular momentum of electron in the nth orbit. That means as electron is revolving around the nucleus, that must be orbital angular momentum, and this is very straightforward because it comes from the Bohr's quantum condition. What was that? mvnrn, which is angular momentum, should be equals to nh by 2 pi. So, this is actually the angular momentum of the electron which is revolving the nth level. So, it is nh by 2 pi. So, clearly ln is proportional to n, just proportional. That means, if you increase the orbit, increase the n, the angular momentum will be increased and linearly increased. Okay. So, you can write it L1, L2 is to L3 goes on equals to 1 is to 2 is to 3 and so on. Now, if you want to evaluate the value, then also we can evaluate, it will be just h by 2 pi, that means h cross 6.626 into 10 to the power 34 joule second divided by 2 pi, which 1.06 into 10 to the power minus 34 joule second, and the L2 will be 2 L1 and this thing. Okay. So, this is the angular momentum. So, application of the Bohr atomic structure is, we can say that the mathematical part we have discussed totally. In last class we discussed the radius part, radius of the electron. Here we have first discussed the energy of the electron in the nth orbit. We discussed this formula, the Rydberg constant, and then discussed why the energy is negative. Okay, the potential energy is negative, we discussed, I forgot, but the kinetic energy is positive, but this is the magnitude of potential energy is greater than magnitude of kinetic energy, that means overall energy is negative, that is why. Okay, this is the energy values and this is the energy plots, energy levels of, this is the energy levels in terms of energy, but actual picture is, what is the actual picture? Just here is the nucleus, around this is the first orbit, but radius is increased, right? Energy decrease was radius is increased like this. Okay, but in terms of energy, the energy levels are like, looks like this. Okay, so this, okay. Now the after that, the speed of the electron in the nth orbit, so we can evaluate this general formula, and in first orbit the speed is maximum. If you increase the orbit number, then the quantum number n, the speed will be decreased. Okay, essentially it will be decreased linearly as well. So, and this alpha is called Sommerfield's fine splitting constant, fine structure constant. This is 1 by 137, which gives us that V1 is, it should be 2.18 into 10 to the power 6 meter per second, that is 137 times less than the speed of the light. Then we evaluated the orbital angular momentum of the electron in the nth orbit. So, this part is okay. Now, okay, we will going to start very important part, that is atomic spectra, very important, obviously for hydrogen atom. Okay. So, let me stop here in this part because this part will take time. So, in next part we will continue we will discuss in detail the atomic spectra for hydrogen atom. So, thank you.